Now, as I said, don't worry about Brunelleschi. Don't feel sorry for him. We're going to follow him right now. He's going to do amazing things. We're going to leave Ghiberti busy to his work in front of the baptistry. And here, he's going to complete these doors first, okay? So they look good, right? Great job, Ghiberti. You're doing good. We're going to come back to Ghiberti in a little bit, but I just wanted you to see that he does complete one set of the two sets of double doors that he's won in that contest. They look remarkably similar to the previous doors, right? Which I guess, it makes sense. He's supposed to complete the job, so he's completing it by making it look exactly like that. Now, let's leave Ghiberti to work on these doors and his next set of doors, and let's see what Brunelleschi's up to at this time. Well, Brunelleschi is mad. He was so upset that he did not win the commission for the baptistry doors that he goes off in a huff to Rome. He's like, what the, Ghiberti's younger than me. I'm a well-established artist. I should have got that commission. So he goes to hang out with his friends in Rome. Now, his friends include artists, architects, also mathematicians, physicians, philosophers, and together they go out to the ruins of the ancient Roman city. So here I've given you two shots of ancient Rome as it stands today, and I want you to use your imagination that a lot of these fallen or dilapidated temples and forums and palaces were literally littering all of the city of Rome. They were everywhere. And so Brunelleschi and his friends, because this is a Renaissance, love to go out and look at these feats of engineering and architecture and sketch them out. Now, what I'm trying to do with you here is kind of, paint a picture, art history joke, paint a picture of this scene, because Brunelleschi is there with all of these other friends who are good at math and good at science and good at physics, and all of them, plus many other around Europe, are wrestling with the idea of how to make this three-dimensional world on a two-dimensional surface. How do we make the large or infinite expanse of the physical world relatable on a flat surface? How do we make it more realistic? And so Brunelleschi, with all of his friends, going around the town, and they're sketching out stuff. Oh, I just love this building. And they're like, how can I make this more realistic? How can I make the lines of perspective that I see to create this dimension that we've been trying so hard to do? Guess what? Brunelleschi is often credited with developing a system. System is called linear perspective. Let me pull out a little bit here. Here. So our term, linear perspective. This is a method of creating the illusion of three-dimensional space by delineating a horizon line and multiple orthogonal lines. These recede to meet at one or more points on the horizon, called vanishing points, giving the appearance of spatial depth. Now, I know what you're probably thinking. If you haven't taken a drawing class, or more specifically a 3D drawing class, then you might be like, this doesn't make any sense. What are you talking about? This is all garbly-goo-goo. That is understandable. So let's walk through this together. What we see when we talk about linear line perspective is a way of mathematically mimicking what our two eyeballs see in our three-dimensional world. How do our two eyeballs receive information and understand things as farther away versus closer? What we, with our two eyes, do is we create a point in the distance, that point in which everything seems to appear to recede or point down to. Those lines of recession are called orthogonals. Got it? And they simply rest, or they come to meet at our eye level. Wherever that eye level is creates a vanishing point, or multiple vanishing points on the eye level. I have a video. I'm going to have you watch it. I'm going to link it to this lecture. So you're going to watch this. It's going to be much more helpful. I'm just introducing it to you. So we have a horizon line and a vanishing point. And the horizon line is the line in which the horizon meets the ground. That's the horizon line. And our vanishing points will meet, or our orthogonals will meet at that vanishing point. Ugh, I'm making such a mess of this. Okay, all of this to say that Brunelleschi is often credited with inventing linear perspective. Now, I don't want to take away credit, but I will say we got to put this into perspective. I couldn't resist. What I mean is that while he is one who helped develop and then spread this system of perspective, we have seen other artists, previous artists, attempt at a sense of perspective. Like whom? Well, do you remember this work of art? The Sala della Pace? And we saw an attempt at linear perspective. We have our orthogonal lines that seem to recede. However, there is no clear system of a vanishing point on a horizon line, and while we have the attempt at those recessions into space that create depth, it's not quite as realistic as what we see in Brunelleschi's system of linear perspective. So what's Brunelleschi going to do with this? Oh, well, he's going to go back to Florence. That's what he's going to do. He's going to go back to Florence and he's going to try it out. And he's not going to just go try it out on any building. He's going to go back to the baptistry and try it out there. Yeah. So it's like, hey, Ghiberti, good job. Okay, can you move out of the way? And he starts to sketch out, using linear perspective, starts to sketch out the baptistry structure itself. And he comes up with something like this. Obviously, I just, printed this out and put some Sharpie marks on it. But let's use our imagination. Let's pretend that this is the sketch by Brunelleschi. So he does his sketch, and then right at the horizon line, in the center of the structure, he pokes a hole through the drawing so that he could look through this hole. Why? Because he wants to test out his theory of perspective. And in order to do that, he needs to manipulate his own perspective. How so? This diagram here. So this is here to kind of show you how he checks on it. Now, you're going to imagine that I am Brunelleschi right here, right? And I'm looking at and sketching the baptistry over here. Okay. Got my perspective drawing. Now, I'm going to take a mirror. See this mirror? And I'm going to take my drawing with the hole in it, and turning the drawing away from me, I'm going to look through the hole. What should I see when I look through the hole? That's right. I should see the baptistry, and I do. Oh, there's that baptistry. There's Ghiberti, and he's working on those doors. Okay. Move out of the way, Ghiberti. I got to check this out. Takes his mirror, and he puts the mirror in front of that eye line. So now what is reflected? What does he see? He sees the reflection of the drawing he made. He sees his linear perspective drawing instead of the actual building. Why does he do this? Well, he's trying to see if it matches up. I see the building. I see my drawing. I see the building. I see my drawing. Do they line up? Do they match? Does the perspective that I've captured in my drawing makes sense with the actual world in front of me, it's remarkably similar. Yeah. Now, one great thing about Brunelleschi is that not only does he help to develop linear perspective, but then he goes on to share this idea with everybody. Everybody's been grappling with, how do I make this three-dimensional world on a two-dimensional surface? And so what we're going to start to see rapidly is that linear perspective starts to become an element of everybody's designs, everybody's compositions, even Ghiberti. What? Miss Cortez, where are we? We are now at the third set of doors for the baptistry. These are by Ghiberti, and we're going to look at them in more detail in our next video. But what you're going to notice is the influence of Brunelleschi's linear perspective in helping to create space or depth in a two-dimensional surface.